So this is our medical doctor level data only. But what sir said in the morning, you need to check for the basic analysis. Between the doctors, there is any significant difference, cholesterol, between the cholesterol, age, gender. So these kind of question we have given here. The code is with you only. Today morning also, I hope everyone got 3 codes, right? So take the code, open your RStudio first, and take this cholesterol intervention R code 21 May 2025. So take this code, how to take your code using RStudio, file, open script. Okay, file, open script, open this code. So everyone have this code. Please check your desktop or your download folders. I hope people have this code with you. Or check the mail, download it again. So, do you have? What is the first question? Anyone can read? Or not? So, what we have to do? T-test. So, before that, I think you all remember this code. We are going to import our data. How we are going to import our data? File, import. SPSS means SPSS, Excel means Excel, CSV means read or one option is there. So like that you have to choose the corresponding method to import your data. So we are going to import our data. Head of data is we are going to visualize first 6 rows of our data. And string of our data means what are the types of data we have. It's full detail about our data set. I hope you all understand these head of, string of codes. Then our library functions. This is from my data. I have intervention one group. So intervention, treatment and control group kind of thing. By that, I want cholesterol, mean and standard deviation. Just visualize what is the mean difference for the mean for the intervention group and control group. Please run till here. And run t.test also and see is there any difference or not. Are you able to run? Good question. Cholesterol intervention data SQUH. That is the data set name. Thank you for asking that. This is our data set. We have this data set. So are you able to import the data set? Everyone got the data set or not? You need to check where you downloaded the data set. From there only you have to choose. Okay. Able to open it. Yes. So now run till t-test. What is the difference between mean 1 and mean 2? Is there a significant difference? P value is 0.006. Mean difference is 0.3 something, right? 0.255 minus 0.51. So next question test whether the doctor have different kind of patients, younger or patient with different level of cholesterol when they started off baseline. That is our second question. For that, what we have to do? ANOVA for age by doctor. How many doctors we have? 12 doctors we have, right? So for the ANOVA, to run ANOVA in R, you need to use AOV, analysis of variance, AOV, analysis of variance, AOV function. And age is your, here age is your dependent variable, follows tilde factor of medical doctor. See what is the p-value, what is the residuals? T-dot test, why? Did you run the group underscore by? Did you run all this package? Attach data, attach data, did you attach? For everyone it's running or not running? Same error. Data. You are given data name is cholesterol intervention. See, here my data name is data, but if you are calling your data in a different name means you have to change it here. Data, if you are calling it as cholesterol, CHOL means you have to give CHOL. But I given name, I have called my data as a data only. Okay, if you change that means you will get the result. No need to attach, you just attach. Run sir. Control enter. Yeah, attach your data, attach the data. And library of stats is running. Just check. You just. So you need to change the name here. Data, it's not data. It's cholesterol underscore. Create, put here it's data. Because it's very lengthy name, you just give data. Now you run this code. No. Now run this code. Run. You will get. So everyone got the T-dot test. Now run it for ANOVA. What is the p-value? What is the p-value? 0.14. Is it significant? So that it's not significant. So one thing also you can do, just you can try mean for age by medical doctor. If you see means average age for each doctor, treated by the doctor, the patient age. If the means are similar means also there is no significant difference. No need to go for ANOVA and test. Now check what is the third question next. Anyone, could you please read the third question? Anyone? Loud. Has to be categorized as normal, less than or equal to 25 and obese data. So for that, BMI should be categorized first. If else, we are using if else condition. If else BMI is less than 25, code it as normal. If not, take as obese. Okay. So in if condition, the command condition you should give, comma, if the condition is satisfied, what do you want to give? If condition is not satisfied, the next one you need to give. Okay. Then you are going to do the, it's 2 by 2. It's a chi-square. For the chi-square dot test is used. Okay. Just run this. What is the answer? Is it significant? significant, less than 0.001. Okay. What is the next question? What is the next question? Anyone can read? So try it and see if there is any association between or not. Yes, sir. It's in a different folder, sir. Where is the data, sir? Here. This is code, this is data. Yes, now press. Try the next association thing also. Is there significant difference or not? Yes or no? What is the p-value? 0. Less than 0.01, correct? So do the next question also, 5, 6. Now it's running, right? If attached means it won't ask priorly. Priorly, if you attach means it won't ask anything.
Just say for example, data BMI will not be. The BMI will also have before, but here we use double. If we just use BMI, we will be quick.
And why means because we are adding this data $BMI here, so you need to. So what is the fifth and sixth question result? Is it significant? So p-value for fifth one is, what is the p-value for fifth one? Okay, sixth one. So correlation between age and cholesterol. Okay. What is the seventh question? Anyone can read? What was the anyone loud? So what we have to do? Regression. So run the regression. To run the regression, LM is the linear model. So that is the function. Within the function, dependent variable follows independent variable, and data, where what data you are going to analyze, that data you need to mention. Summary of model will give the all the summary. Okay, you just enter model and what are the things you are getting, then run summary of model. So to see what is the difference between just entering model and summary of model. So what is the result you are getting? how to interpret this result? R square, what is the R square value? Just standard error. R square 0.17 adjusted. So how to interpret this BMI? Cholesterol. So which is p value is less than 0.001. So next question. For that, what test we have to do? T-test. So what is the difference? See, I will show. Concordinate function, CAT function is a concordinate function. So one second. So here, if I give regression on equation is beta naught plus beta 1 into BMI. So combine the values with the labels. I am here within the brackets. I am giving within the brackets. I am giving regression equation equal to y, the total cholesterol follow-up is equal to that thing is I am giving. Otherwise, you can give regression equation alone, y equal to, like that also you can, whatever you want to see as an outcome in the end, you can type it using this concordinate function within the double quotes, you can write, and after the quotes, this coefficient from the model, this model, okay, the coefficient from the model. So for that, you shouldn't give the double quotes. Then add. This addition is we are adding. We are writing manually, we are writing. So that should be comes within the quotes. Then comma, coefficient of model 2, that beta 1. That should be from the model. So you shouldn't give within the quotes. Then I want into BMI. That is my independent variable. So concordinate function is to see how to visualize your outcome in a better manner. Then what is the 9th question? So using the ggplot2, that is the package used to visualize the data, your data in a graph. Okay, you can do bar graph, line graph, scatter plot, everything using this ggplot. Okay, here I will explain data, the usual thing only to describe descriptive statistic, mean and standard deviation will take using this function alone, right? So the same way we are taking, we need average BMI value. So these things same for your descriptive code. The extra thing, ggplot, AES, aesthetic means in the graph, what are the things we need? X-axis, Y-axis, X limits, Y limits, and label title, X title, Y title. These are the key things need for the graph, right? So all the things we are mentioning. X-axis, I want mean of BMI and standard deviation as a my line error plot only they are asking, right? So that is using for the confidence interval. Then ggplot geom underscore bar means I want bar graph with my error plot. So for that, this is the command. Bar graph is geom underscore bar, and geom underscore error bar is from, what is this? What is this mean minus 1.9 confidence interval, upper limit and lower limit. So that is we are giving here, and title should be BMI with 95% confidence interval by doctor. So my x-axis doctor 1, doctor 2, doctor 3. My y-axis is BMI mean with the confidence interval bar graph. Okay, so run this, see what is the difference. So this is a graph. The next graph is age. Just run. Are you getting the same picture? This is the subgroup analysis. We will come to this later. Okay. Just go for the 11th linear regression and run it and see what is the regression coefficient value. So BMI shows a significant difference. Intervention is I don't think it's decreasing. So are you able to run the codes? So after the random slope model, we'll come to this and random intercept we will run. Okay. That is the code.
Okay. Hello everyone. Can you everyone hear me? Yeah. Myself Srinivas. Now I'm going to explain how to fit in the naive regression analysis and also how to do random intercept model in RStudio. First, I request all the participants to open the CHOL data, which is a short form of cholesterol. So import the CSV file in the same way like file. Import from text reader. Here there will be the data. Can everyone able to import the data? Okay, this is the data. So we can go through the data over here. Can everyone able to import the data? Just give me a thumbs up if you can. Yeah, we can go through the data here. This is ID, which basically represents the subject, and institution, as you explained, Sarah explained in the previous session, institution level variable, and medical doctor, what are the doctors they are appointed to, medical doctor level, and TC is our outcome, which is total cholesterol over here, and age of the individuals, patients, and BMI of the patients, and also the age of the medical doctor whom they are attending. These are the variables in our data. So we can go to the codes over here. So we can see the data here. Now I'm attaching the data here. First is the naive regression, which is nothing but a simple linear model. So for that, need not to load this package called stats because it is already loaded in your RStudio itself. So we can see the model how we are constructing. So LM is going to be my function, which is the short form of linear model, and TC is my dependent variable or also called as outcome, and age is my independent variable. So data is the cholesterol data what we are going to do. So let me fit this linear model and we can give summary. As you can see over here, this is the estimate slope, which is 0.05. So as you people all know how to interpret the slope by now. So we can see the log likelihood for this model. So the log likelihood is minus 546. So this is the linear model or naive model. So let us see. So before that, I'm trying to construct the interclass correlation. So how I'm going to construct it? So I'm giving a function called as varest, which is nothing but the command called varchar. What this varchar do is that it's going to extract the variance of the mixed effect model, what we are trying to fit. What are the variance will be there? Mostly between groups variance will be there, and variance due to residuals will be there. So I need to extract those things to build my ICC. So here you can see the formula of ICC over here, which is varest of 1, which is nothing but between group variance divided by sum of between group variance and also the residuals, variance of residuals. So basically this is the formula for ICC. So we are constructing a function for ICC for now. So we are constructed. Now we can go to the random intercept model, how to fit it. For that you need a library called as NLME. So I hope everyone have installed this package. If not, try to install it. If everyone have installed it, just give me a thumbs up, that's all. Okay, I hope everyone have installed that package called NLME. So let me load this package. For now, I'm not using the package called LME4. My main package is NLME. So let me see what is the model doing here. The command what I'm giving is LME, which is linear mixed effect. And in fixed command, I'm giving total cholesterol to age, which is my fixed effect. And my random effect is what Sarah explained in previous session. It can be like 1 bar MD, which is basically I'm varying the intercept with respect to the medical doctor level. And method I'm using is maximum likelihood estimation, which is most often used. And the data I'm giving as cholesterol. Let me see the summary of the model. Here you can see the log likelihood minus 405 and also the estimates. That's how you will fit the random intercept model. Is there any doubts here? And we can also calculate the ICC of the model. That's why we have constructed. This is 0.527. This is our ICC. You can also compare it in your book, as you can know that output will be similar. Is there any doubts in this random intercept model, how to fit it? Yeah, package. Okay.
Next exercise is project the data. This is just get the distribution of district code. So this is, we are going outside some other data. You need to think about what should be the model, etc. Okay, this is, give me the district, how many districts are there? Frequency. In R, you use the word table command. Command is table for district. It will give you the, how many districts? How many districts are there? 30 districts are there. So 30 districts, antenatal care surveillance. This is basically the proxy for HIV prevalence. Is there. Just go back to the data. Now, there are two interventions, one or two. One is, I don't know what is what, but one was provided by government, Tamil Nadu government. Another one was provided by CDC and USAID and all this kind of foreign agencies. So the literacy rate of the districts are given to you, the infant mortality. That tells you about how healthy the state is. So these are all just the covariates about the state. And the year means that is where the prevalence was calculated, observed. So you have for each district 6 observations. Is that right? Okay. Now, the first question is that we wanted to, the question was that whether the ANC prevalence was lower for the districts which was funded by foreign agencies as compared to government agencies. Only one agency, government, Tamil Nadu government, TANSA. So therefore you have two interventions. So you have to answer this question. How do you address this question? You have 30 districts. Because you have for each district 6 observations. Observations are correlated. So you have to consider all the observations in your analysis. Okay. And you have two interventions. That is a question you have. So you have to use all the data available to you. And the covariates for the level is IMR and the literacy level. Basically, it is a regression analysis. You need to use 6 observations and district is a cluster. Is that right? So what kind of ICC going on in the data? Districts, C or ICC. Between district variability is ICC. Observations are the ANC statistics. Okay. Repeated measures are 1 to 6. Okay. Now, how do we model it? Okay. Okay. First, we'll do just a random intercept model and assess what is the ICC going on. The covariates are IMR and literacy rate. Okay. And you have time also. You can put time. So you can answer the question, what does a change per year change in your time? Shall we do that exercise? Okay. So you just follow we'll do that exercise. Just go to, you have the R code for that? Read the data. Read the data. Yes. Path. Yeah. Slowly. First import the data. You don't have to change the folder name from your folders. Wait. You're able to read the data? What is it? Random model, name model. Name all plotted. What is this one? What is the data? Where is the name model? Just a regression analysis. Yeah, intervention. No. Intervention plus all the other covariates you can put. Anyway, right. Okay, wait. So the ANC, this is if you look at, do you have this output with you? Just run the name model, taking intervention. Intervention is the focus of our analysis. It says there is a negative correlation as you move from intervention 1 to 2, there is a declining ANC rate. Okay, I'll tell you what is true later on. Okay. So now, is it significant? Yes, it is significant. The naive analysis says that there is a significant reduction in between the two. If you do a t-test, you will get the same results. Now the next question is, you allow the districts to vary. That is a random intercept model. Do you have the code for random intercept? Where is it? Wait. You explain each piece. So remember the delta 1 I said that is one given district code. That is a code intervention. This model, you do this model.
As I said previously, I have used the package called NME4 was there. So this is the model structure which is according to this package. Why I have used this means in the outcome you can see missing values. So this package can remove those missing values, whereas LME cannot remove that. That's why I have used this. But you can also use that code once previously instructed. Before that, you have to remove the missing value. That's the only difference. You can also try it.
How do you remove the missing values? Do you remember any command? Na.omit. Okay. So what is where is the analysis? How much is the ICC? ICC has to be calculated. Where is the variance? Where is the intercept variance? Random effect, fixed effect. Do you have this one ICC? It will give you the variance data. Where is it? Come down. Results section you come. Where is? No, it will give you as maybe that is it's not giving the standard error, the standard deviation. Come down. That is all. Where is it? Yeah. So now what is ICC? But there's something is missing in the code. So you should not use that. Do you see, do you remember the standard deviation, something which I put? What is a standard deviation variance by the district, by residual, and the total? If you have the previous code, copy and paste and run that code.
Just replace the video.
How much is the ICC?
Yeah, you have to remove it.
There's no missing values in the data. It's giving error. Yeah. Say again, some question. Wait. Now, this is what I said. The first job is to find out what is the ICC. Now tell me what is the total variance in the data. 0.28 plus 0.41. So that is, 69, is that right? 0.69 is total variability. Our interest is that intercept. So let's say 0.3, 0.28 or 0.3 divided by 0.9, it's 30%. ICC is around 30%. Is that right? So what we do not know is it important or no, not important, and that kind of thing which we don't know, but we need to adjust for it. So it gives you exactly how much is the ICC going on between districts. Now, so now we'll introduce, now the question, what is the next question you have? What is the naive model likelihood and random intercept model likelihood? We need to compare and see whether we should have a intercept model at all. So how much is the likelihood?
For the name.
Log likelihood is -109. So this is -13 for the naive model. Do you get this value? -123.
Likelihood value.
Repeat it again with this. Is it the code which you have used earlier morning, that same code you used is better. So you don't introduce too many codes. You just. Do you get log likelihood values? That is a name model likelihood is minus 123. Minus 123. Do you have this data, this value? Okay. When you introduce a random intercept, just go to the random intercept model. How much is a log likelihood is minus 1.9. How much is the difference? Please raise your hand if you don't get these values. Are you okay? Use your old code and run it and see. Are you able to get that values? Are you okay? Now tell me, do you need a random intercept model?
See, you have to type or copy the code from the random intercept, random slope, that code document, copy the model to ln6 and change the variable accordingly and run this one. So you will get the ANC log likelihood value in this model. Then compare with the simple linear regression.
Maybe start from all over. Okay. That is he introduced some. Just start from the old code and see. We'll redo it. So we'll take the old code which we did in the morning and do the analysis. Okay. Read the data.
So this is our old code, right?
So clear it. Basically, take the old code, clear everything. This is the old code.
Yes.
Do you have this code, old code? Okay. Now, so read.
So this is the cholesterol data.
So instead of cholesterol data, you just change the
In we will do this ANC data itself. Okay. So read your clear everything. Control. If you click in the console window, Control L. If you click Control L means it will clear your console page. Okay.
wait a minute. Did he send this code? This is based on the old code only.
Yeah.
Okay, same concept. Okay. Do you have this code loaded? Yes. Yeah. Loaded? Yes. Now run the this model. What is that? Name model. Read the data.
So this is my data.
Okay.
So now we are going to run the full model.
Where is name model?
This is simple linear model.
Okay. Please run this model. 2B, model 2B.
This one. Run this.
That is a simple model. So what is the likelihood? Likelihood is minus 123. This is your likelihood. So the regression coefficient is this. Intervention is okay. This is okay. This is the standard error and it is statistically significant. There is a significant reduction from 1 to 2 in terms of ANC prevalence. So the funding agencies have provided funding for 6 years. End of 6 years, they wanted to evaluate it really worked. And the next question is, which funding agencies doing very well? The districts belong to those funding agencies. I'll tell you what is 1 and 2. Okay. Is that clear? That is a question. It says overall there is a reduction in prevalence, ANC prevalence after 6 years. and between 1 and 2, the two funding agencies. If you move from 1 to 2, there is a significant reduction, but you don't know what is 2, code 2. Now the question is, allow the districts to vary. Allows the districts to have different intercepts. So you introduce random intercept model. Which model is that?
The mixed effect model ANC. So this is district code we are giving A.
Yeah.
So
Delta 1 given intercept
ANC difference from
district code.
intervention. And here random. Shall I run this?
Yeah. Do you have this code with you? So we're allowing the districts to vary. Random intercept. Do you have this code? Let's make sure that you have this code. So
Sorry.
rather than-
And NA dot omit. We have to give NA dot omit.
there are some missing values.
Yeah.
The ACCs that log likelihood is 109. Earlier, how much was the
Minus 123.
123? The difference is, let's say,
20,
14 or something.
14.
14. So for 1 degree of freedom extra, because you have put one extra parameter, that is your random intercept, into the model. For 1 degree of freedom extra, you need to have minimum 4 chi-square. How much is the difference? 18 we have difference. 124 to 109 is 24 units difference. So highly significant. It suggests that we should have a random intercept model. Let me ask you a question. If I have only 1 year data, not 6 year data, what analysis you would do? He's saying fixed effect analysis, just only 1 year data, starting data, first year data you have 33 districts, intervention 1 and 2, 30 districts. What analysis you would do? Simple regression. The question of multi-level or repeated measures data analysis does not exist at all, because the question comes because 6 observations you have, whether they are clustered together within the districts. Okay, and it varies from other districts, between districts variability. When you have only 1 observation, we don't ask that question at all. This is just a simple regression analysis. Okay, now, so because it says that district level analysis is necessary. Okay, after the last lecture, we'll see how do we bring in other covariates into the model. It's very simple. Now, it says that this is the random intercept analysis is necessary. How much is the ICC? 0.32. Okay, 0.32. Now let's see whether the covariates are important in the analysis. Okay, we are going to adjust for, there are some districts, not because of the funding, it is because of the literacy level of those districts and healthy status of those districts, and so on and so forth. Therefore, you put those variables into the regression analysis and see, you are adjusting for the covariates, IMR and literacy rate. So introduce that one into the model.
Yeah, simple models.
You have, yeah. Now how to do that, plus you let add, plus
1 second. Names of.
IMR one.
I am not.
No, just put it in the random model. Oh, this is a distinct, okay. IMR,
Simple.
yeah, correct. Plus one more literacy. Other variables did not make any contribution, I think. What is our now the likelihood is how much? Like
105, previously 109.
4. By adding the variables, it does not improve any predictions or whatever. It's just doesn't make any difference whether you add the covariates or not in the analysis. Now the next question is, do you understand this one? It says that you should adjust for your regression analysis. It will be adjusted for this thing. Intervention is not significant. The intervention is after adjusting. Earlier, it was highly significant. So somebody can explain this results to me. Earlier, the intervention was significant. There's a significant reduction in the naive model as well as the random intercept model. But when you adjust for your IMR and literacy rate, that intervention effect disappeared. What does it mean to us? The intervention is not the actual one which reduced the ANC rate. It is because of the other factors like IMR and literacy rate really contributed to the reduction in ANC prevalence. So the funding agencies would have claimed that they have brought down the ANC prevalence. It is because of the inherent statistics of this districts like IMR and this. Now, so if you do only that much of analysis without adding the covariates, you would not know the real picture. You would claim that intervention has done significant reduction in the ANC prevalence. The 2 was basically government funding, Tamil Nadu government funding, TANSAX funding. The 1 is from other agencies. In fact, Tamil Nadu government funding really contributed to the reduction earlier without adjusting for this covariates. The saying was, the Tamil Nadu government has picked up all the good districts in their program. Anyway, that will automatically come down. All the poor districts were given to foreign agencies. That is why they were still at that level. If you draw the graph, and you would know what is happening. Okay, this is the level has to be looked at that way. Now, similarly, if I have to say, for example, southern districts, southern states, if I have the data for southern states, do you want to bring any other level into the analysis? Then you would bring the state level into the higher level and do the analysis. It's the next level, if you have the data. So something you should plan like that. What is the next level? Is it necessary? And so on and so forth. So this is basically, now let us look at randoms. What we have seen so far is random intercept model. Now we'll have to look at random intercept and random slope. Please remember, you can't have a random slope without random intercept. The line has to touch the intercept, therefore random intercept. The question is, do you want to have a random slope? or not. That means random intercept and random slope. What does it mean in our example? Each doctor and their patients are allowed to have a different slope. Why should I assume that they all follow similar pattern? The slope is similar for all doctors. I don't have to think that way. Therefore, allow the doctors to have a random intercept and random slope. But the question has to be addressed is, do we need random slope? Okay, do we need random slope? So therefore, you have the log likelihood to compare, and at the same time, how does it change your random intercept parameters? Other covariates, the age is your covariate of interest, whether it changes its standard error or magnitude, etc. That is what we are going to do. I'll do this lecture. Very simple only. Yeah, this way.